Hello and welcome to the second part of our naming. So what we're going to be looking at today, still a review of grade 10, but we're going to be looking at naming polyatomic compounds. So what polyatomic means is it means many. It essentially just means more than two. So before we were looking at binary, now we're looking at something that's maybe got 3 or 4 atoms that are grouped together. Polyatomic compounds contain what's called a polyatomic ion. A polyatomic ion is 2 or more atoms that are treated as a single unit, and they actually have a single oxidation state or a single charge. So, for example, a common polyatomic that we're going to see is called carbonate. Carbonate is CO3, and it's got a charge of 2 negative. So carbonate actually can't be broken up we don't break up carbonate into individual carbon and oxygen. As a whole, anytime we see CO3, we call it carbonate, and carbonate itself has a charge of, or an oxidation state of 2 negative. So in order to actually name compounds of polyatomic, you are going to need 2 tools. So we want to make sure we have those tools ready. So the 2 tools that you are going to need is going to be your periodic table. So your periodic table I've already got here for you. So your periodic table here, you want to make sure that you have it open. I have mine open and ready to go. And the other thing that you want to double check and make sure you have is called a polyatomic chart. So this is going to be a list of all the polyatomic ions. You want to make sure that this is open as well too. And it's going to tell you exactly what the polyatomic ions are and also what their charges are. So I'm going to have both of these open and ready. So that way, as I go through naming, they're at my disposal. So let's take a look at polyatomic ions and how we name them. So we name substances containing polyatomic ions the same way we name binary compounds. So polyatomic ions are going to form ionic compounds. Who knew? So just a reminder, with ionic compounds, we are not using prefixes. So we are going to use no prefixes when we go through and when we name them. When we write the formula, we are going to use the crossing over rule. So essentially, when we look at this, the first thing that I want to help you with is how to know you are dealing with a polyatomic and not a binary. That is very simple. Binary, remember, always has 2 types of atoms. Polyatomic has more than 2. So the first thing you want to do is you want to check for how many capital letters you have. If you have more than 2 capital letters, you are dealing with a polyatomic compound. So in my first example here, Na2SO4, I've got 3 capital letters. I must be dealing with a polyatomic compound. Next up, I want to actually identify what my polyatomic compound is. So most of the time, your polyatomic compound is going to come second. So I'm going to go ahead and I'm going to see if I can find this SO4 on my list over here. So I'm going to go to my polyatomic list, and I'm going to see if I can find SO4. So I can see I've got SO4 here. So SO4 has the name of sulfate. So instead of saying SO4, I'm going to go ahead and I'm going to say sulfate. So I would call this sulfate. So SO4 is considered to be sulfate. My other compound, Na, well, we know that as sodium. So I've got my 2 compounds here. I've got Na sodium. I've got SO4 sulfate. Remember that you're not using prefixes because these are ionic. So this 2 doesn't matter here. All that matters is the fact that I have a sodium and I have a sulfate. Next up, I have 4 capital letters. So if I have 4 capital letters, this suggests that I actually have 2 polyatomic compounds. So I'm going to have 1 polyatomic compound here, and I'm going to have the second polyatomic compound here. I want to go ahead, take a look at my chart and see what each of these stand for. So my first one here is NH4. So I'm going to take a look at my chart, NH4. I'm going to see if I can find it. It's under my face. Okay. No, let's just do this. There we go. I found it. It is over here, and it is ammonium. So I'm going to go ahead and I'm going to write NH4 as ammonium. So let's go back here. And NH4 actually sounds like ammonium. So we're going to write that in here. Now, next up, I have to find CO3. So I'm going to go ahead and I'm going to take a look at CO3. CO3 is up here. I mentioned it before at the beginning of the note. That's carbonate. So CO3, instead of writing CO3, I'm going to write the word carbonate. And we are going to go ahead and call this carbonate. All right, next compound, I again have 3 letters. So I have my first letter here, PB, and I have my second round of letters here, NO3. So first of all, PB, that's one that we're not familiar with. So I'm going to go ahead and I'm going to find PB on the periodic table. So I'm going to pull up my periodic table. I'm going to look for PB, and I'm going to find that PB is lead. Now, as soon as I see where lead is on the periodic table, I get a little bit nervous because these are where some of my multivalent metals are. So I'm going to go ahead, I'm going to zoom into lead, and just what I thought, lead actually has 2 charges listed. So all the rules that we learned about ionic compounds before are still going to apply to polyatomic. When it's a multivalent metal, when it has 2 different oxidation states, I do still have to figure out what the charge of that oxidation state is. So I'm going to have to figure out the charge. So for now, I'm going to go ahead, I'm going to write lead. I'm going to write the brackets to remind myself that I'm going to need Roman numerals. I'm going to find what the name of this polyatomic ion is first. So NO3, I'm going to go ahead, I'm going to take a look at my chart here. So I'm going to go back to my polyatomic chart. I'm going to find NO3, and I can see NO3 is right here. It is nitrate. So I'm going to go ahead and I'm going to write nitrate. Now, all that I have left to do is to figure out what that charge of that lead is. Well, nitrate, from the polyatomic chart, it said it had a charge of -1. Lead, we don't know what lead's charge is, but remember that this went under the crossing over rule. So whatever number was written here actually ended up next to nitrate. So I'm going to go ahead, I'm going to look at this number right here. I see it's a 2, so that means that lead must have a charge of 2. So when I go through and I write this, I'm going to go ahead, I'm going to call this lead. I'm going to write 2. Those are the Roman numerals for 2. Lead 2 nitrate. This last example here, so again, I have 3 capital letters. I've got my N, I've got my H, and I've got my C in Cl. Now here, this is a bit of a tricky one. The reason why it's a tricky one is because our polyatomic ion is actually written first in this case. So most of the time, 99% of the time, your polyatomic ion is going to be your last 2 letters. There's only going to be one example of a polyatomic ion ever written first. That's because there's only one positive polyatomic ion, and that's ammonium. So anytime that you see the letters NH4 first, that's your polyatomic ion. If you don't see those 2 letters first, then your polyatomic ion is automatically the second part of your compound. So here we've got NH4 written first. NH4 is ammonium. So I'm going to go ahead and I'm going to write ammonium. And then this second element here, that's chlorine. So I'm going to go ahead and name it just like I would any other binary compound. I'm going to name it chloride. So if we have a regular element that's not a polyatomic compound, and it's your second element, we go ahead, we drop the last 3 letters, and we call it ide. So that's how we name polyatomic ions. Let's go ahead and let's take a look at how we write the formulas for polyatomic ions. So remember, polyatomic ions, or our ionic bonds, that means that we are going to use the same crossing over rule that we did for our ionic compounds. So we're going to use the crossing over rule just like we did before. So aluminum sulfate. Now the other question is, how do I know I'm dealing with a polyatomic compound when I'm looking at the name? The key here is you want to look at the ending. Most of the time, unless you're dealing with ammonium, your ending is going to be different. So remember, our ending for regular binary ionic compounds was always ide. Now your ending is not going to be ide. So I can see the ending 8. I've got the ending 8. The ending 8. So the first clue that you've got a polyatomic compound is if it's got an ending 8 or if it's got the ending ite. There's 2 exceptions to this. We'll deal with those later. Right now, we're just trying to learn how to do this. So we're going to always look for the ending 8 or the ending ite. Here I've got an 8 ending, so it's my clue that I am in fact dealing with a polyatomic compound. So I need to go ahead and I need to figure out what sulfate is. So I'm going to take a look at my polyatomic compound. I'm going to look at sulfate. I can see sulfate right here. And sulfate, the polyatomic ion, is SO4, and I do want to include the charge. So the charge here is 2 negative. So I'm going to go ahead and I'm going to write SO4. And my charge is 2 negative. Then my other element here is just an element like we've seen before. So aluminum, the symbol is Al, and Al has a charge of 3+. Now I want to go ahead and just like before, I want to cross over. So this 3 is going to come down here, and this 2 is going to come down here. So we're going to write that like this. We're going to have aluminum, and the charge that's next to aluminum is going to be this 2 from sulfate. And then sulfate, what's going to be next to sulfate is going to be this 3 from aluminum. Now here, it's a little bit tricky. You might remember this from grade 10. What you've essentially told me here is you've told me that you've got 2 aluminums, you've got 1 sulfur, and you've got 43 oxygens. That is not correct. That's not what you have. You have 2 aluminums, and you're trying to communicate that you have 3 sulfates. So anytime you're crossing over a charge to a polyatomic ion, and there's already a number there, you need to use brackets. When I put brackets around it, what you're now telling me is I have 3 sulfates. I have 3 SO4s rather than saying you have 43 oxygens. So anytime you're crossing over a charge and you find there's already a number there, you need to put brackets around it to make sure that you're reporting the correct numbers. So let's try the next one. We are going to try potassium dichromate. So again, I've got an 8 ending. Since I have an 8 ending, I'm going to go ahead and I'm going to look at my polyatomic chart, and I'm going to see if I can find dichromate. So I'm going to look, and I'm going to see if I can find dichromate. So I'm going to take a quick look here. Okay, that happens sometimes. That's okay. So we have something that we actually don't have it on. Oh, no, we do right here. I found it. So dichromate's over here. So dichromate is Cr2O7 2 negative. So Cr2O7 2 negative. So I'm going to go ahead. I'm going to write that down. That's what dichromate is. It's Cr2O7 2 negative. Now I need to figure out what potassium is. Well, potassium is just K. It's in the first group on the periodic table, so it's got a charge of +1. I'm going to go ahead and I'm going to cross my charges over. So I'm going to write this out, KCr2O7. Now the 1 from potassium is going to go next to chromate, but remember, I don't actually have to write a 1. So I'm not going to write that 1. And the 2 that's next to chromate is going to go next to potassium. So we're going to see a nice 2 there. All right, I want you to go ahead and try the next one on your own. So pause the video, see if you can figure it out. There's a couple other ionic naming rules in there. I'm sure that you've got it. Now I'll do it with you. So again, we notice that we've got that 8 ending. Since we've got that 8 ending, I want to go to my polyatomic chart and I want to figure out what phosphate is. Phosphate on your polyatomic chart is PO4 with a charge of -3. The trick here, copper, is actually a multivalent metal. It's got multiple oxidation states. So this number here, this Roman numeral, is actually telling you what the oxidation state of copper is. So copper in this case actually has a charge of 2+. So we're going to go ahead and we are going to write this out, and we are going to cross over our charges. So this 2 here is going to come next to phosphate. Remember, anytime that I place a number next to a polyatomic ion, I need to place those brackets around it. And then this 3 here is going to go next to copper. So I'm going to place a 3 here now. All right, why don't you go ahead and see if you can find a trick that I put in the last one for you. So pause the video, see what you get. Again, we've got that 8 ending. So if we've got the 8 ending, we know it's a polyatomic ion. The polyatomic ion with the 8 ending carbonate is CO3. 2 negative. So carbonate is CO3 2 negative. Magnesium is just from the periodic table, Mg. It's in the second column, so it's got a charge of 2 plus. You would then go ahead and you would cross over those charges. So we would cross over our charges. So Mg and the, MgCO3 and the 2 for magnesium would come down here. And the 2 from carbonate would come down here. But remember, we reduce when we can. So since these charges are the same, since they're both 2, they're going to go ahead, they're going to reduce, they're going to cancel out, and we're just going to be left with MgCO3. So the chemical formula for magnesium carbonate would be MgCO3. Quickly, before we get to the last couple 8 endings that we're dealing with, I want to show you kind of the 2 exceptions that you might see. So the 2 times that you might not have an 8 ending. Let's take a look at your polyatomic chart, and I'm going to show them to you right now. There's one polyatomic ion that doesn't have an 8 ending, and that polyatomic ion is hydroxide. So if you look at the top here, it's got an "ide" ending. It looks like hydride, but it's not. It's hydroxide. So you want to be really careful when you're reading those polyatomic ions that you don't see the word hydroxide and miss that it's a polyatomic ion. So hydroxide is a polyatomic ion. Even though it has that "ide" ending, the polyatomic ion is OH1 negative. We're going to see this compound a lot when we talk about acids and bases more in Unit 4. The other time you might not have an 8 ending is if your polyatomic ion comes first. So if your polyatomic ion comes first, you're not going to have an 8 or an "ite" ending. You're going to have a regular "ide" ending. The only time that's going to happen is if ammonium is your polyatomic ion that comes first. So if you have the word ammonium in it, you are dealing with a polyatomic ion as well. You'll eventually figure this out because you're going to spend like an hour looking at the periodic table trying to find the element ammonium. It's not going to be on there because it's a polyatomic ion. So instead, you want to look at this chart over here. Now, one thing that I want to point out, there's sometimes polyatomic ions that we could give you that might not be on that chart, and that has to do with the number of oxygens. So this is the last thing that I want to look at with you, and this is going to be the possible polyatomic ions formed with oxyanions. So essentially, an oxyanion is just any combination of oxygen. So we're going to look at our polyatomic ions, and we're going to see that most of them actually have oxygen in them. What can vary is the amount of oxygen that they have. So anything that has that 8 ending, can I get this to go? Can I get my highlighter working? Maybe, possibly. If not, that's okay. You can just read along on my screen. I just want to see if I can get it going. Nope, that's okay. So anything that has that 8 ending, still no. Anything that has that 8 ending here is considered to be the base polyatomic ion. It's what you work from. So if we take a look at our polyatomic ion chart, we've got nitrate. So nitrate is our base, NO3. So our base has 3 oxygens. We have sulfate. So again, sulfate is our base with 4 oxygens. We have bromate with 3 oxygens. So anything that has this 8 ending is considered to be the base number of oxygens. You can then have something that has an "ite" ending. If something has an "ite" ending, it means it has 1 less oxygen than you would normally expect to see. So anything that has an "ite" ending has 1 less in the base. So for example, if we take a look at nitrite, nitrite is 1 less oxygen than nitrate. So nitrite only has 2 oxygens, nitrate has 3. If we take a look at sulfite, sulfite only has 3 oxygens, whereas sulfate has 4 oxygens. So again, you have 1 less oxygen than you see in the base. So ite just means that you have 1 less. So for example, I might give you a question where it says bromite, right? So here, we don't have bromite on the bromite on the polyatomic chart, but what we do have is we have bromate. So we could actually figure out what bromite is. Bromite would be 1 less oxygen than here. So instead of having 3 oxygens, bromite would be BrO, that was rough, BrO3. O2. So bromite would be one less oxygen. It would be BrO2. So ite means one less than 8. We have two other examples of that. Hypoite is two less oxygens than your base, and we've already seen that before with peroxides, is one more oxygen. So we've got a nice example here that helps to illustrate that. So chlorate would be considered to be the base. So if we look up what chlorate is on the polyatomic chart, chlorate, can't highlight, that's okay, I'll just point to it. Chlorate is ClO3. So the base here is chlorate, ClO3. One less chlorite is ClO2. Two less hypochlorite. So we want to look at two less than the base. Well, what's two less than 3? 1. So hypochlorite is only going to have one oxygen, whereas perchlorate is going to be one more than the base. Perchlorate is going to be, well, what's more than 3? 4. So you actually would use these prefixes, hypo, ite, or per, to actually modify what's on the polyatomic chart. You're going to see that on your assignment that you're going to practice. So at the bottom of this page, you're going to see a practice assignment. I want you to go through their polyatomic compounds. I want you to go through and I want you to try practicing on your own how to name polyatomic compounds. At the bottom of this lesson, you'll also see the answers for those assignments. I challenge you, make sure that you go through first and try to figure it out yourself first. Don't just look at the answers and try to figure it out from there. I want you to actually practice. So go through, practice, look at them, and then once you actually finish your practice, then you can go ahead and you can move on to the assignment. So that's it for actual naming review. We do have one new thing that we want to look at, and that is going to be the naming of acids, and that's going to be at our next video. So tune in for our next video and the last one for this unit, where we teach you something brand new and we talk about how to name acids, and then we're done. All right, have a great day and we'll see you later.